We are going to have some scatter plot stuff on here as well. Fairly easy questions. Okay, we should be really good at scatter plots. We just did them. It probably won't take us a whole lot of review to get through them. All right, R squared is what the correlation coefficient is for that over there. Okay, looking at that scatter plot. Looking at that scatter plot. Would you say that this graph is linear, quadratic, or neither? I'd say linear. I could see how you would say quadratic because it's kind of the bottom of a parabola. We would make it more obvious than that. Okay, so don't let that be too fancy here. I would say it's linear. You could draw a line like that pretty closely models my data. Okay, so it is a linear equation. Is the correlation positive, negative, or neither? Why is it negative here? My line is going down. The higher as unemployment rate drops, the GDP ratio increases. The last one says, is the correlation strong, weak, or none? Strong. How can you tell that it's strong? They're close. What else about this problem? The dots are close together. What else would tell you that it has strong correlation? My R squared is close to 1. Anything above 0.5 would we consider strong. The following data on speed, miles per hour, and mileage is shown below. This graph, look at they drew in the best fit line for you. So this line right here, would you say that line is linear, quadratic, or neither? They drew a line in here. Yeah, okay. I see what you're saying there. I would say because they drew in the best fit line, let's use it. That line that I drew, regardless of quit looking at the dots. That line that I drew in, is that line a straight line or a parabola-looking line? That makes it quadratic. Okay, so I understand where we're saying there in terms of, oh, the dots aren't very good. I don't disagree with that. Okay, if they give you the best fit line, let's assume that that's what we got. Is the correlation? Oh, I don't want to do this one. This is part B. Oh, good. I don't have to do this one. You do that one. Let's go to the next one. You can do the rest. It's not hard. Which way is the parabola going, up or down? So what do you think, positive or negative correlation? All right. Yeah, because the parabola's going down. Convert from degrees to radians. So this is what we just did the other day, converting from degrees to radians. What we are always going to multiply by a fraction. When we're converting from degrees to radians, it's always a fraction. Okay? So we're going to multiply this by a fraction. What are the two numbers? What are the two things that are going to be in the fraction when we multiply? Pi and 180. Okay? Half of a circle. Pi and 180 degrees. This problem currently, we are trying to make it into radians. So does that mean we want pi in our answer, or are we going to try to take pi out of our answer? We want to put it in. All right, so that means pi has to go on top, and 180 has to go on bottom. When we're talking about radians, we do not want to make it a decimal. We want to reduce the fraction. So use some really basic reducing skills. What can I reduce from both the top and the bottom? I can cancel out a 0. Divide by 10. So that gives me 21 pi over 18. What number can I divide both 21 and 18 by? I can divide them both by 3. So if I divide 21 by 3, it gives me 7. And if I divide 18 by 3, it gets me 6. Done. 7 pi over 6 should have been my answer. Number 18, convert it to degrees. Okay, so it's in radians. For us, that means it has pi in it right now. I want to get it so pi is out of the equation. Okay, so where does pi need to go when I set up my fraction? Pi goes on bottom, 180 goes on top. We're going to try to simplify. What can I simplify here? Cross out the pi's. Those go away. I get 2 times 180 divided by 3. I would love for you to be able to do that in your head, but if you can't, use your calculator. 2 times 180. That's going to be 360. Okay, then you're taking 360 and dividing it by 3. So you can use your brain. 360 divided by 3 should get you 120. 120 degrees. Last one. Determine the arc length, rounded 2 decimal places. Here is my problem. We are trying to find the arc length. So our ultimate job here is to find the distance of the line from there to there. How long is that line? That's what we're trying to figure out. Okay, so from here, let me zoom in a little more. There we go. What was our formula for arc length again? Somebody remind me. Anybody remember? Something, something, something. S equals R theta. That's our formula. S stands for arc length. That's what we're looking for here. What does R stand for? It stands for radius. What is theta going to stand for? That's our angle, and more specifically, what has to be true about that angle? It's got to be in radians. It needs to be in radians. So do we need to convert our answer here, this pi over 2? No, it's already in radians. It's got pi in it already. It's not a degree angle. Okay, so all I need to do, S is going to be equal to R, which is 8, times our angle in radians, which is pi over 2. Don't overthink it. Plug it into your calculator. See what you get. 8 times pi over 2. Use the pi button. Plug it in. Hit enter. It said rounded 2 decimals, so my final answer here is 12.57. That's the test. If you go back and we're good at this, you're going to do well.